Okay, welcome. Today we're going to be talking about some of the latest research in the field of the vagus nerve and generally around interoception today. So interoception is the field of study of all the sensations that come up through your body into your brain. So you perceive things from the external world through your five senses, but you'll also have a whole set of about 42 senses that come up from your vagus nerve alone. So that's pretty incredible. So if you know how to look for your vagus nerve sensations, you are in a much better place. You're not kind of chasing around like I have symptoms, but now you can know actually, oh, this is a vagus nerve thing. This is a vagus nerve thing as well. So let's take a crack at this. So this is published just maybe a week ago, and it's called In the Body's Eye, the Computational Anatomy of Interoceptive Inference. And also, just for this, so you guys know, this is also a helpful understanding of what do you need to look at when you're looking at a research paper, because I don't want to just come in here in this Facebook group and then just page vomit a bunch of information. It would be great if in the future I still shared my takes, but if you're able to go and research on your own some of the stuff in this field, you're going to be a lot better off, and you end up becoming, if you ever become client of mine in our program, then you're the kind of person I like to work with, someone who can at least try to digest some of this research. So let me just check on what you can see here. Okay. All right, so I'm going to do some highlighting. So a growing body of evidence highlights the intricate linkage of exteroceptive perception to the rhythmic activity of the visceral body. So what that's pointing to is that there are certain clocks that operate in your brain, and there are clocks that operate in your body. And when they're synced, they go they sync up like a clock, like two different clocks, and they record. One sends information and one receives it, and they have to receive and send in the same window of time. But if your clocks get off kilter, then you have something like this: sending information and then stopping sending, and then your brain is in the receiving state, but there's nothing there. And so you get this completely opposite synchronization between your brain and your body signals. That's why you can get kind of numbness in some parts of your body, or you can have dysbiosis. So when it comes to the vagus nerve, we showed a study just last week on the resynchronization of your brain and your stomach and your digestive tract by stimulating your vagus nerve through the ear. Right? There's a research that showed low-grade, low-intensity electrical stimulation of the ear immediately resynchronized the clocks over again. And I'm not talking about it took days or whatever. It took seconds. As soon as it was turned on, they measured brain activity and stomach activity. And somebody who was dysbiotic, meaning their stomach wasn't working properly, the synchronization went back into synchronization, which is really incredible. So people who are like, I have gut issues, I have digestive issues, all those kinds of things, maybe it's not bacterial overgrowth. Maybe it's just that your brain and body are not syncing properly. And so this is the field of interoception. So, in parallel to your body, interoceptive inference theories of affective perception and self-consciousness are on the rise in cognitive science. However, thus far, no formal theory has emerged to integrate these twin domains. Instead, most extant work is perceptual in nature, meaning, self-assessments, writing on a pad of paper, I feel good, I feel bad, but nothing too technical. So here we introduce a formal model of cardiac active inference, which explains how ascending cardiac signals from the vagus nerve entrain exteroceptive sensory perception and uncertainty. Through simulated psychophysics, we reproduce the defensive startle reflex and commonly reported effects linking the cardiac cycle to affective behavior. So this is looking at the fear network in the brain, and then how that shuts down the vagus nerve so that the heart is no longer under the vagus nerve's control, meaning that you have a high heart rate. So if your vagus nerve is active, it should have a downward regulatory effect on your heart in cycles. Your vagus nerve goes on and off, on and off. And if your vagus nerve is off, your heart rate just goes wild, and then that can persist if you are still either sick or whatever. We further show that simulated interoceptive lesions blunt affective expectations, induce psychosomatic hallucinations, and exacerbate biases in perceptual uncertainty. So by interfering with the vagus nerve, they showed that it blunts expectations, right? So you have lower expectations on what's possible. That's where you get people that are demotivated in a sense. Then you have inducing psychosomatic hallucinations of persecution, of maybe, some form of depression that's keeping you ruminating on the same things, happen when you simulate interoceptive lesions, meaning you stop the input of the vagus nerve into the brain. You have disassociation, bad thinking, psychosomatic hallucinations, and they exacerbate our biases and perceptual uncertainty. So you become much more closed off when your vagus nerve doesn't work. So through synthetic heart rate variability analysis, we use HRV to measure in large part the activity or inactivity of the vagus nerve through heart rate variability. We illustrate how the balance of arousal priors and visceral prediction errors produces disyncratic patterns of physiological activity. That means that more desynchronization leads to even more desynchronization. Our model thus offers a roadmap for computationally phenotyping disorders of brain and body interaction. Okay? So just the one interesting thing here was they did a study, and as part of the same study that we're looking at right now, is they had people guess when something would happen, and they presented a picture of a spider, essentially, at certain windows. So when their heart was beating, and there were certain times where the vagus nerve was more active versus less active, they were able to sneak information into the brain when the vagus nerve was inactive that caused some form of sensory hallucination, meaning there's a spider, and the brain sees a flash of a spider at a time when the vagus nerve is inactive, and the person has a hallucination that there are spiders around them. More or less, that's what this is showing. So it shows that if you become highly frightened and highly startled, the reason it's probably so severe is because you have less vagal nerve regulation. And so a treatment for startled fear responses would be to re-engage interoceptive awareness by measuring your heart rate variability. So I just found this to be extremely interesting. And you can go read more about that paper. I'll put the link here in the description. Let me close that. But yeah, that would be this research right here, just published. Very, very interesting. I'm going to plug that in here. Boop. So yeah, vagus nerve issues can lead to more issues. Here's another one. This is actually pretty exciting. So this one's called Neuromodulation using computer-altered music to treat a 10-year-old child unresponsive to standard interventions for functional neurological disorder. So this is really wild. Now, this comes out of the work of Stephen Porges. So respect to Stephen Porges for helping to contribute to this. This is the Safe and Sound protocol that we're talking about here, and it does turn out that it was a success. So the case history was Marie-Therese, known as MT, was a 10-year-old girl. So 10-year-old girl in 5 of primary school referred to the mind-body program by a pediatrician for treatment of functional somatic symptoms. Unsteady gait, meaning they can't walk properly, blurry vision, periods of confusion or appearing dazed, and persisting headache that had been triggered in the context of a viral illness. MT lived with her parents, a younger sister, and her grandmother. Both parents worked full-time as architects. The family history included rheumatoid arthritis, so an autoimmune issue, epilepsy, a vagus nerve issue, and type 2 diabetes, a hormonal vagal issue as well. So on the mother's side of the family, and colorectal cancer, grandfather on the father's side. MT had been diagnosed with celiac disease at age 6, which was being managed with a gluten-free diet. So I'll just kind of skip to the bottom and just show you some stuff. But this was the basically how the researchers described the process was to essentially treat brain stress systems. Essentially, that's kind of what they're trying to do with this study. And if we go down to the very, very bottom, just read the conclusion. There's some cool questions. Where is it? Safe and Sound protocol. Okay. So the Safe and Sound protocol was added to MT's outpatient treatment program 7 weeks after her discharge. During the intervening periods, her symptoms had persisted. The 5-hour intervention was delivered in 9 sessions over 6 weeks with a 15-minute block and building to 30 minutes. During the first session, MT reported that the music made her ears feel funny. She settled after a 5-minute break. In the next sessions, resulting in a total 3 hours of music, MT became chatty during the sessions, engaged in mindfulness coloring in exercises, but would move restlessly in her wheelchair toward the end of the session. At this point in the treatment, the MT's parents reported that she had started walking around the house, utilizing the walls as support, something that she had been previously too anxious to try. Her physical therapist, outside psychologist, and her school teacher all reported that she had become more engaged in her therapies and in school. MT also began to actively use the regulation strategies she had previously learned, for example, slow breathing and managing catastrophic thoughts to settle herself when she felt her body activating. Cool. So I'm going to share the research for that too. You could definitely go check that out. That is the Safe and Sound protocol, essentially. And yeah, it's really good. Really good. Sometimes I talk about polyvagal theory, but Safe and Sound as a therapy does seem to activate some parts of the autonomic system. So that's awesome. Moving on, I want to look at this one real quick. This is just a sense of the kind of work that I end up reading more often than that kind of stuff, because I think it's like single cases are cool, but it's really a good skill set to be able to understand the nucleus, Tractus, Solitarius, which is part of your brainstem, which is part of your vagus nerve. And so they're charting these neurons that control feeding behaviors via projections to the paraventricular hypothalamus. So let's see if there's any kind of pictures here. Not necessarily, but I'll just show you this. So this is corollary to some of the work that you might see with stimulating the vagus nerve itself. So when you activate the NTS neurons, it reduces chow intake and body weight, okay? So food intake. So this is why vagus nerve stimulation is an approved therapy for treating obesity. It is an approved therapy for treating weight issues. They will actually do a vagus nerve implant in humans, and it actually works effectively for regulating food intake because it lets people feel that they're actually full. Oftentimes, the people who are overeating so much are doing so because their brain is not receiving the signals that should be telling them to stop eating. So anyway, this is just more validation of that process, that by activating specific neurons in the NTS, you would specifically be able to modulate some of your, I guess, effects, some of the behaviors that you have around food. So very interesting, very interesting. I'll throw that in the chat too. Kind of interesting thing. So if you're dealing with weight issues, maybe looking at the vagus nerve as a stimulation location could be a good idea, potentially. But let's see if there's any. Not so much of a conclusion here, but it's a very interesting thing to map the functions of the vagus nerve to different things. So activation of the NTS neurons suppresses food intake. So if you're an overeater, you may want to explore some form of vagus nerve stimulation. It could be very helpful. So I believe I shared that in the chat. And then the other one, which I think is really big, really excited about this one, is this. Transcutaneous auricular vagus nerve immediate stimulation treatment for treatment-resistant depression, a functional magnetic resonance imaging study. This is a really big deal. This study is really good. So it's in Frontiers in Neurology. So it's a very excellent publication. And so we'll scroll down through here and just look at what we've got here. So the objective was essentially to stimulate the vagus nerve. So objective, transcutaneous auricular vagus nerve stimulation. I'm going to share this link in the chat right now so you have that. And then I'm also going to share the link to the free guide that will teach you how to do this. So let me pin this. So if this catches your ear and you know of somebody that is like needs their vagus nerve stimulated, there's a free online course at veguscure.com. You go register an account. It's free to register. You log in, and then you get access to an entire dashboard of all the equipment that you can get to stimulate your vagus nerve in the exact same way that this study laid out. So, and this is not the only study. There are hundreds now of studies showing the effects of stimulating the ear in human patients and how well it helps manage a lot of vagus nerve dysfunction. So if you're really new to this and you're like, I want to at least try some form of vagus nerve stimulation, then go to veguscure.com, and it's a fully backed, scientifically informed training course where you can go and get the exact same equipment that these guys used in their study and what's really used in clinics all over the world. So going back to it, the objective of this study is transcutaneous auricular vagus nerve stimulation, and they want to do the objective is to discover if it's effective for treatment-resistant depression, TRD. And the current study reserved the immediate modulating effects of TAVNS in patients with TRD using rest state functional magnetic resonance imaging, which is fMRI. So they had people in a big fMRI chamber while their ear was being stimulated, and they found that it selectively changed brain activity in the orbital prefrontal cortex. So it's very, very cool. Let me make sure you can see the conclusion as well. I'll just scroll up here a little bit. This was on 40 patients, and they had some healthy controls. So it's probably about 2020. So let's look at the conclusion. Conclusion: this study applied fMRI technology to examine the effects of VNS stimulation treatment on the brain activity of TRD. Excuse me. These results suggest that the brain response of TRD patients to VNS treatment may be associated with the functional modulation of cortical regions, including the medial orbital frontal cortex. So that's a part of the brain where, in my work, when we stimulated the brain with ultrasound, we found the exact same types of decrease in depression scores. And so I'll post the website if you want to go and look at our long history of study on ultrasound stimulation. You can go here, reddit.com/ultrasonic neuromodulation. And that's an entire place where you can go and actually read more about the studies on brain stimulation with ultrasound and other forms of neurological treatment with ultrasound. It's very exciting. We even talk about ultrasound as a form of stimulation for the vagus nerve, which I believe, out of all the ways that you could stimulate your vagus nerve, ultrasound is by far the best option. It takes less time. It's not painful, unlike electrical stimulation, and it seems to last longer for patients, meaning as soon as you stop doing treatment of electrical stimulation, your body basically defaults back to its original state. So it's, is it good for initial treatment? Yeah, probably. If it's the first line of defense you have, I would say go for it. But just know, depending on how long of a result you want, you're probably going to want to actually incorporate ultrasound instead of electrical stimulation of the ear. So just so you know, but you can go read all about that research at the link provided, reddit.com/UNOMOD, ultrasonic neuromodulation, or UNOMOD. So you can go there today and see years of research on that. So let's see. The left anterior parietal gyrus and the left superior marginal regions. Changes in these neuroimaging indices may represent the neural mechanisms underlying VNS immediate stimulation treatment in TRD. So this study is a proposed research effect to understand what part of the brain is changing when you stimulate the vagus nerve. And so I want to see if I can Google this real quick, which would be what is it? VNS coma. Gonna look at that. Here we go. This is really, really cool. So I just wanted to share this as well, which is the hold on, where is it? I don't have the picture here. But this was a study on vagus nerve stimulation after traumatic brain injury and expression in the prefrontal cortex. So this is previous research that went into, I believe was cited by the last one, but they were able to stimulate the vagus nerve and actually help wake brain activity up post-coma. So if it was a traumatic brain injury and there was a coma involved, they would use vagus nerve stimulation to actually increase brain activity, which is pretty wild. So I just want to share that. And then the other one would be the images, which was right here. I think pretty darn incredible. This study I really am like blown away by, honestly. So here it is. Continue. Oh, come on. I just want that picture. Jeez. All right. That's from, I think, Nature or whatever. I just want to get you the pictures. Here we go. Go away. So many pop-ups. Okay, so I think you can see this. So here we go. Brain stimulation partly awakens patient after 15 years in vegetative state. So you can see on the left, this is a magnetic resonance imaging of a brain in a coma. And on the right side is the stimulation applied from the vagus nerve with the ear, electrically speaking, and you see this huge spike in overall brain activity. So you can partially wake up patients that are in a coma by stimulating the vagus nerve. Okay? Pretty amazing. I'll post this link in the chat too, so you can go read that later if you want. Boop. Did I get that wrong? UNM. Hold on. All right, I got to check on the subreddit. But anyway, where are we at? Yeah, okay. So brain stimulation with stimulating of the ear of the vagus nerve was extremely successful. Okay. So anyway, let's wrap it up there. That's kind of the main takeaways from this week. I think the last one we're looking at here is that the vagus nerve, when applied, when electrical activity is applied to the ear, you do get really a pretty effective treatment of depression, treatment-resistant depression, which is really hard to treat. And so just by stimulating right in the ear, you can get results for treating of depression. So that's pretty cool. So yeah, if you're interested in that, you can go to the website vaguscure.com, where there's an actual guide on how to assemble these exact same ear clips. Well, they're slightly different ear clips, but they're the same concept, and you can clip onto the ear just like that. And yeah, use them. It's available. It's easy to get. You can get the equipment today, tomorrow, whenever. But yeah, and I'll take you there. I'll just go to vaguscure.com so you can see what that looks like. So when you go here, you're going to be at, let me shrink this up a little bit, make it more readable. So when you go to vaguscure.com, you'll be able to log into the mini course. And first you do is you make a new member account for the mini course, and then you'll be able to log in with the password and email you used, and then you're in. So it's I kind of call it the vagus nerve survival course. So it's like, hey, I need some immediate help. I want to start stimulating my vagus nerve. Using essential oils and breathing does not seem to be doing it for me, and I want to take things to the next level. This would be the place to go. So it's vaguscure.com, and really easy to go. You'll just log into the course, and everything's there. So definitely recommended. So anyway, I'm going to end it there. Thanks so much on YouTube for watching. Like, comment, and subscribe if you like this content, if you like learning, and if you like learning resources that can help you and others in your immediate vicinity. Because vagus nerve stimulation is actually something that's very easy to replicate in others if you've done it yourself just a few times. So imagine we're putting tools in your hands that you could literally go out and help people in your local community, in your family, your friends. I have friends that I recommend Vagus Cure to, and they message me with like, oh my God, I had I was having kind of bipolar-like symptoms, and those are relieved. I had digestive issues. Those are relieved. So there's a lot of cool stuff that you can do with the vagus nerve. And so anyway, we share all this just so you know that there's a wide array of research going on with this field, and that it's actually very safe to do. And I think we've got a couple thousand people who've gone to this website and are using it currently. So you're in good company for that, for sure. So anyway, thanks so much for watching on YouTube. Like, comment, subscribe, all that good fun jazz if you liked what we saw today. And I'll see you later on the next one, YouTube. Bye-bye.